Okay, so to prevent that same problem, what we need to do is ensure that we end up with a prefix-free encoding. So let's look at one such prefix-free encoding. And so that means that no character or symbol is in the prefix of another symbol. So for example, I could have 0, I could have B be 10, C could be 110, and D could be 111. So if I look at the 0, you don't see that at the beginning of any other character. If I have 10, you don't see that at the beginning of any other character or symbol. This one starts with 11, this one starts with 11. And while these both start with 11, the one on the right doesn't start with 110. So it's really the prefix part. You never see a symbol that is found in the prefix of another symbol, which would sort of hide it, and we wouldn't know which one was it, which character it was. So now we know exactly where one character ends, another one starts. That's what you can do with a prefix-free encoding. So why would this be a good idea? Well, if you take this example here, let's say we need to store a lot of A's. Well, if we store 100 A's using the fixed length encoding, we would use 200 bits. And if we store 100 A's using this encoding, we would use 100 bits. Well, you might say, well, what if I store a bunch of C's too? Well, if you store a bunch of C's, this wouldn't be a good encoding. But let's say we store a bunch of A's and 100 A's and only 5, let's say, C's. Well, if we store 5 C's, that would be 5 times 2 is 10. That's 210 bits. And then 5 C's for this one, that's 5 times 3 is 15. And we add those two together, and you're using 115 bits. So it depends on if you're expecting some characters to come up more than others. If you're sort of uniform in your usage of each of the possible symbols, then you wouldn't really need a prefix-free or a variable length encoding, actually. But as we'll see later on, a Huffman code will handle that situation perfectly fine, and you'll just end up with essentially a fixed length encoding from the Huffman algorithm. All right, well, let's take a more precise look at this. Let's say that we analyzed some text and we're trying to compress it, and what we found is that the A is about 60% of the characters or symbols, B is 25%, C is 10%, and D is 5%. So comparing these two encodings, what are the average bit lengths for them? Well, the answer for the first row is pretty simple. Since every character always takes 2 bits, the average is going to be 2 bits. For the second one, we have to do a weighted average. So we have to actually take into account that 60% of them take 1 bit, 10% or 25% take 2 bits. So we would say 1 bit times 0.6 plus 2 bits times 0.25 plus, and since both of these 3 bits, we can just add those percentage together, times 0.15, and what you'll get there is 1.55 bits. So on average, we would use fewer bits in our prefix-free encoding when you compare that to the fixed encoding.